So let's get started then. Hey everybody. Might have been a long time since we've seen each other. But I hope everyone's doing good. So today we're gonna start with one of the microbit projects. So the first thing we're going to be doing today is we're going to be building out one of the things you might have played around with in the past on the microbit. And what that is collision detection. So by collision detection, what we mean is, can our little robot that we're making, can this robot see that there's an object in front of it and take an action? So you will get to decide what that action is. In my code, what our code is going to be doing today is we're going to be having the robot walk forward like we want it to, like a standard car, like a standard robot. And then the second it sees an obstacle and it sees it right in front of it, what we're going to have it do is just freeze where it is, and maybe even have it turn around or some other action. So that's what we're going to be building from scratch. So the way that this video is going to work, I'm going to build it with you, and I'm going to just talk you through what I'm doing as I'm doing it. So at any point you like, you can pause the video, you can have a look where you are in the code. I'm going to try and explain it line by line, even just say what I'm thinking as I'm building stuff, and then I think that should really help you in terms of understanding what you're doing, and even better, building some really cool things yourself. So let's get started. So if you look on the screen at the moment, there's a few projects you might remember from before, but the first one we're going to do is going to be completely starting from scratch. So obviously the first thing that we need to do is make a new project. So we're going to call this collision bot. We don't have to worry about code options for now. This will come later when we have our own languages under our belt, think like Python and JavaScript. So for the moment, all you need to do is give it a cool name and hit create. So if you've come to any lessons before, this should be familiar to you, but here's the make code interface. This is where we start with all our code. We have the on start block, which is the code block that runs once when we first run our code, and then we have the forever loop, which is the thing that keeps going on and keeps rerunning every single time until our little robot or our little microbit blows up, dies, or goes somewhere terrible. Hopefully not up against the wall or anything like that. So our forever loop is the thing that is always running. So we're going to use that to write all our code inside. So if you think of it, one of the best ways to think of it is it's like turning on the ignition in a car. So the start block is like turning the key. So oil gets injected into the engine. I wish I knew more about mechanics. The engine gets put into the oil. I assume there's a starter switch that gets hit, and that only needs to happen at the beginning, because once the engine gets started, that engine will be running forever until we turn the engine off. So on start, in our code, I can't think of anything we'd like to do yet, but on our forever loop, we're going to begin writing our code. So the first thing we're going to do is we're going to write a little message that lets us know that the robot's working properly. So the second that we turn on our car or our robot, what we're going to have it do is say a message to us. So show string is about, and you can see actually what's going on here. There's a virtual version of our microbit which we can use to get feedback on how our code's working. So when we look to the left over here, for example, if I show the string code, we can wait a second, and then the little microbit or the virtual microbit, the simulated microbit that's on our screen, will show us what that would do if we were running the code. If we hit this small button here, we can even restart the simulator, which means imagining that we just like when you plug in your microbit and you flash new code to it and then it runs for the first time, that's all. We're doing the exact same thing with our virtual microbits. So here we go. And this is a really useful tool because it can get annoying sometimes always having to drag your code and go back and forth. You don't always have to do that. So obviously we can't simulate the robotics parts of our whole robot setup because that's additional kit, but just for the basic stuff, like anything that we could just see on our microbit alone, we can simulate all of that just through our computer. So that can often save you lots of time. So for example, just moving beyond the first line now, we know that when we start our program, it's going to just say code once. And as you can see, it only runs that once, because remembering on start is something that only happens once when we first fire up or first turn on our microbit with our code written to it. An important thing to remember is that when we are talking about our code being on the microbit, we write our code on our computers, obviously, but then when it's completed, when we have a version of it that we want to save and that we want to actually run, we take that code and then we place it on the microbit. There's a lot of different names for this process, but we can call this flashing, we can call this downloading, and actually this is the one that MakeCode uses. So if you see in the bottom left where my thumb or my hand is at the moment, when we use this download button, if we're lucky, what this is going to do is if our microbit is plugged in, then what it's going to do is it's going to take the code from MakeCode and put it straight onto the microbit for us. So that what we've been running and what we've written will start running. If it's written correctly, it will then start running on the microbit for us, which is great. That's what we want, because we don't just want the code to work on our computer, we want it to work on our robot. So remembering that's always what we need to do. So for example, I'm going to now download, if you haven't written this line, write this line and then test whether you can download your code. So if yours is working like mine, you'll see this downloading sign, and you'll also see a flashing yellow light on the back of your microbit. That's when it's flashing, it's a sign that something's being written to it. So be patient. It's always important that patience is such an important thing for a programmer. So we're just going to wait for that to tell us that it's done. Take a breather, look out the window, anything's good. Me, I'm going to put my phone on silent. Not just so it doesn't distract me, but so it doesn't interrupt this recording. Great. So I'm just going to record a video of what this is doing. So just to show you what this is doing, I'm going to download my code again. I can see that I've got a flashing yellow light. Got a flashing yellow light on the back, and now just like my computer does on the virtual microbit, I've now got my actual microbit saying code. So that's great. So that's the first thing. So let's have a message that makes sense, right? So when our microbit turns on, we're going to have it say on, just as a little message to us, because we can imagine that when we run our code, it will be quite confusing to know, is it working? Is it not working? Have I got the power on? Have I got the power off? So if we always have a message that runs when everything is right, if the power's on and the microbit's plugged in, it will always say on when it comes on, and that's always useful for us to know. So after it says on, we want to have the microbit give us a message to say it's about to start. So basically the engine is running. So we're just going to have it show a small message. So we don't want a long word, because we don't want, so like it actually takes time for our program to, for example, show a long message or show a string, because as you saw, it has to go across the whole screen. So we're going to show something simple that just lets us know that the program is doing well. So you can pick another symbol. Remember, all you need to do to change some of these code blocks is just click on this small drop down menu. Lots of these functions, and these functions are what these are called. These functions or code blocks, if there seems like a bit that you can write in or a bit that you can click on, have a go and see what options you have, because there's loads of other things that you can do with that. For example, there's smiley faces, musical notes, even a trident, a pitchfork, and all kinds of shapes. The one we're going to do is just have a smiley face, and so long as there's a smiley face then in our forever loop, we know that the program is working. So as you can see on the virtual microbit now, we can see it's showing a smiley face, and because it's in the forever loop, it keeps showing that smiley face again and again and again and again. So I'm going to download that to my microbit. just to check that it works, and you can do the same. So what we expect now is for on start it to say the word on and then launch into this forever loop. And because it keeps saying forever show icon, forever show icon, forever show icon, it keeps looping round and round and round, we're always going to have that smiley face until we write some more stuff now. So the first thing we're going to do now is we're going to get straight into setting up to use the McQueen robot parts. So the first bit we're going to do is we're going to click on this settings tab, and then we're going to go into extensions. In extensions, what extensions is just all the extra code that's out there. So if you think about basic input, music, LED, radio, all of these bits of code that are already written for us, somebody had to write those, and many of them are actually programmers just like you now. And how this works is we call these libraries or modules, and this is code that's already been written for us that we can just access and we can just reuse. So a lot of programming is about reusing code that's already been written, and it's often very small bits, and then you add all the creativity to take all these small bits and make something much better out of them. So think all these small code blocks, we take them and we build an actual collision detecting robot, or a raving robot, or a flying drone. We build all those things out of just these small parts. But we're not, why we have extensions is because we're not just limited to these basic ones that come out of the box. We can actually go and we can find loads more that other companies, other programmers, other people have shared and want us to use. So what we're really lucky to have with the McQueen robots is that we have the ability to just get some McQueen code. And I think we've been familiar with this in the past. So we search McQueen, obviously you need an internet connection, and then you click on McQueen. And now you're going to download all the extra robot code. And as you can see, it pops up. You have McQueen IR, which we won't be using right now, and then you have McQueen. And in here, we have a load of great things. So I'll just break down what some of this does, and then we'll talk more about that later on. So the first bit is read ultrasonic sensor. So if you can see in your box or with your parts, you have what looks is like a blue rectangle with what looks like two eyes on it, or two goggles. So that's your ultrasonic sensor. So ultrasonic sensor, it's about sending out a signal. It's about sending out a wave, actually. So if you've seen ultrasound during pregnancy or with babies, so they use ultrasonic waves they press it to the stomach of the woman, and by bouncing the waves off of the baby, they can make an image. So at a really basic level, we're doing the same thing. So just like bats do, when you might know about how bats work out, even though they have very poor very poor sight or no sight, the way that bats, or maybe even Batman, if you watch any of these cartoons or read the comics, uses ultrasound. It makes a very large noise, or sends out a signal, waits for it to bounce back off an object, and then depending on how long it takes to bounce back, you can work out how far something is. So we're doing the same thing with our ultrasonic sensors. So how those goggles or that sensor works is it shoots out ultrasonic waves in front of it. And as an example, thinking of it like a tennis ball. If you threw a tennis ball against a wall and you threw it and it took 2 seconds to come back to you, you'd know it was 2 seconds away, or the wall was 2 seconds away. We're lucky that we can use maths to work out that, let's say we're throwing the ball at 1 meter a second, then if it takes 2 seconds to come back to us, then we know the wall is a certain distance away. So that's all we're doing. We're using ultrasonic waves to tell us how far away we are. So we're really lucky with the code that it does all these calculations before. We don't need to know exactly how it's working. We can just know that if we read from the ultrasonic sensor, which is to say that if at any time we just go, how far away am I, then the ultrasonic sensor will tell us. And we can choose whether that's in centimeters or, well, in this one it's only centimeters. So that's what read ultrasonic sensor does. Servo S1 angle we'll come to later, but that's about using some motors and equipment on the robot that will let us move equipment. So we don't need to use that in this project. Motor left, move forward at speed 0. So this is actually about turning on the individual wheels. So remembering, if you can see a drop down menu, that's something you can click and something you can change. What this will do, and we will be using this, is turn on and off our motors, our wheels. So if you've got the wheels on your robot, this is a great way of testing. So we're going to actually use this one. So we have the option of moving left, right, or all. What a good thing to check out if you want to pause the video and experiment with this is which one is the left one and which one is the right one. If you don't want to know the answer, pause the video now and work it out for yourself. But if you point the microbit forward facing, so if you think that the LEDs or the headlights on the microbit are facing forwards, then this is the direction that you use to work out what's left and right. So the microbit is no longer facing at you. If you've got it pointed the right way, it should now be pointing away from you. And the headlights should be pointing away from you as well. The left wheel is the one that's on your left, and the right one is now the one that's on your right. It can get a little bit confusing because depending on which way you look at it, a different one is the left and the right. But now you know. And this also applies to the forward and the backwards movement. So the forward will always be the one that moves it in the direction of the headlights, and the backwards will always be the one that takes it the other way. Speed, we have a range of numbers from 0 to 255. So that's for you to experiment with what speed is best for your robot. I'll often use just halfway because we can always turn it up and then we can always bring it back down again. But that's basically all the things we can change about the motor. And we don't have to turn them on individually. Like we don't have to say, it's like in a car, you don't have an accelerator for the left tire, or say it's the left tires and the right tires. You just have an accelerator that turns them all. And we have the same thing with the robot. So that's what we're going to use. So the first thing we're going to test is whether we can get all the robot wheels to spin. If you haven't built your robot already, then make sure you do that. Pause the video, follow the instructions that are in the box, and you can get back up to speed. If you've just come back, or if I'm just carrying on now, we're going to just turn on all the wheels at once, just to make sure that everything works. You'll need your batteries plugged in, you'll need to make sure the power's on, which will be at the back. And what we're going to do is we're going to switch on all the motors, just to check that everything's working all right. So what we're going to do is we're going to say to turn on all the motors and move them all forwards. And we're going to do this at, let's say, 150. Remember that we can specify any speed. We can do it by a number or we can do it by dragging this bar. It's up to you. So Maker gives you loads of ways to change these things, but use whichever one makes most sense to you. So remembering to do all the steps. If we've been here before, we remember how to do this. So we're going to download our code now. Pressing download. And remember, this time I need you to pick up the microbit because it is going to run off if it's got any power. And remembering also, you do need to have your microbit plugged in for you to get the code, and for the microbit wheels to turn, you're going to need to have your battery pack plugged in. If you haven't got if you don't know, if you find this isn't working at this stage, make sure that the batteries are charged. I've had an experience where they weren't working and it gets very confusing trying to work out what's going on. So if you are having problems with this, the first thing you want to change or check is the motors. So my code is just flashing at the moment and I'm waiting for it to turn on. I've got it in my hand. Still downloading. Still downloading. So sometimes what will happen, just as it did there, the code might not download directly to the microbit. So if you're not getting the behavior you expect, then you do have an option. You can make sure that the code is on the microbit. So what you'll do then, if you download again, work straight away. So now I can see my wheels are spinning. Hopefully yours are doing the same. So what I'm going to do, just because I don't want it to run away from me while I'm programming, is I'm going to pause it there, and I'm going to turn it off at the back, then I can put it down safely, because we don't want our stuff getting damaged. So now we know how to turn the microbit robots on and off. So that's the first thing. We know how to make it go forwards or backwards. If you wanted to go backwards, just out of interest, we would take the same code. We don't need to change anything apart from just this small bit that changes the direction. If you feel like, oh, that's simple to me, we're making sure that this makes sense to everyone. And if you feel like we're stating the obvious, just keep listening, because we're going to get more complicated. So again, I'm going to this time download the code again. I'm going to turn the power back on my robot at the back, and then I'm going to hold and wait to see what it does. And things are working. So I turn my power off again. So next, we're going to think about how do we get it moving and doing motion detection. So at a very basic thing, what we've done now is we have a smiley face on the microbit that tells us, oh, it's on. And we also have an action that tells us that we have an action. We've chosen to make it go backwards, or we can make it do anything we like. So what we're going to do now is to go to two other really important features. So we don't just want, if we start putting multiple commands for our robot to perform, it might get confused. So for example, if we did motor all move backwards and then motor all move forwards right after each other, there isn't a break between these things being, well, it's like we're having a conversation with these robots. There's no break between us saying go backwards and go forwards. So imagine you were running a race, or you're playing football, and your manager or your coach was shouting at you, going backwards, forwards, backwards, forwards, backwards, forwards, backwards, forwards. Which one would you listen to? You wouldn't even be able to move before you had to follow the other one. So you'd probably just stay still. So we're gonna grab this code, and then we're going to see what it does and see if it causes us any problems. Just out of interest, and just to make sure you know what's going on here, I've added a pause afterwards, so we might be able to observe the behavior. So turning the microbit back on, downloading the new code, and for some reason, even though we've got a backwards command, all the computer does is go forwards, which is very confusing, because it never goes backwards. But the reason why that is because we've just skipped over it. Because we go backwards, forwards, because the code always runs downwards, in the smallest possible time, because there isn't a break, that we tell the robot to go forwards, so that it doesn't even have any time to go backwards before it moves on to the next command. So that exact kind of situation is the reason why we put in pauses. So if you go into basic, just where I did, and grab pause in milliseconds, what this does, with 1,000 milliseconds being in a second, what this does is it puts a break in between our commands. So for now, as opposed to saying backwards, forwards, which is what we were doing before, now what we're going to be doing is going backwards, waiting a second, and then going forwards. So the robot's actually got time to do what we asked it to do before it moves on to the next one. And just so this becomes really clear, we're going to have a pause once we say backwards. So we go backwards, wait, forwards, and wait again. And that way the robot's got 1 second to do each of these things before it does the next thing. So if you copy this into your own code now, and you see what this does, again, we're going to go through the same cycle. We're going to download the code onto our microbits and see how this is different. You might, before you run it, might want to think, what do I expect this to do? And then we can get started. So I'm going to download my code, and you can do the same. So I just made a rookie error, and I didn't turn my microbit on, but the code is still on there. So the second that you turn it on, the code will run. So when you're turning your microbit on and off at the back, you're not making it so that the code either does or doesn't download. The code always downloads so long as it's plugged in. The difference is that the code only runs when the microbit or the robot's been turned on. So the second that I turn this on, it goes forwards and then backwards. So if you're seeing the same thing as me, now your wheels are going forwards and backwards. So I turned it off again, because we're now set up. So at a basic level, we completely understand now. How do I turn on one wheel? The answer being, I click right here and I go left or right. How do I turn on both wheels? I click on all. How do I move them backwards? I click on this drop down and I choose backwards. If I want to go forwards with whatever wheel I've chosen, I click forwards, and then here's how I change the speed, either writing in a number or dragging. How do I decide how long the robot is going to do this particular thing for? I put a pause in right after the command so that I give this certain amount of time for it to actually do that command. So just like we changed the speed, if I wanted to say do this for 10 seconds, I'll go 10,000 milliseconds. I'm just checking I did the right amount of ones and zeros. So that was 100 seconds. So this is 10 seconds. Remembering that there's 1,000 milliseconds in a second. So times however many seconds you want the microbit to listen to that particular command for by 1,000. So for me, I want it to pause for 10,000 seconds, 10 seconds. So I'm going to pause it for 10,000 milliseconds. And if you now run this code again, what you'll see is that it pauses. It goes backwards for 10 seconds and forwards for 1. But you can take that one on me, and the next bit we're going to do is now think about how do we get motion detection working. So we're going to change our code a little bit now. So for at least just our test, what we're going to do is we're going to delete these two blocks, and actually we're going to take a few seconds just to talk about what some of these do. If you're thinking, how has he done that? What I do is I right click on any code block, and it gives me the option to duplicate, which is like a copy and paste all in one. And if you see whatever you duplicate, you get an exact copy of that for you to drag somewhere else. This can be really useful, especially when you're writing complex code, because you might not want to repeat a whole code block again. So it also gives you the option to delete it, which is really helpful for cleaning up like we just did. Another one we can do is add a comment. So we can add little notes to ourselves to explain things for later. Or for example, if we want to send our code to someone else, we can leave notes like this. So for example, I would leave a note that said, this is the code to move the microbit robot at the start. And that means that there's just a nice little note. And also, you don't expect to know what your code does forever. If you're doing a lot of coding, you'll move from project to project, and you might not remember what really complicated things did later on. So little comments like that can be really helpful. And as you can see, it doesn't have to clutter up your screen. when you click on this, it pops back out. And then when you click on that again, it disappears. So you can write in these comments and never need to come back to them. But it's always a good thing to add those comments so you remember what they did later. Writing comments as you go, just like journaling, it can be a good way of also processing your thoughts as you do this. And you might come up with new ideas as you go through and comment the code. It's being like, oh, why I did this like this, and then go, oh, wait, that wasn't a good idea. And you might do it another way. So let's talk about, without writing another line of code, how we're going to make what we expect and what we want to write our code to do. So what we want to write our code to do is when we put it down and turn on the power on, it's going to walk straight forwards. And the second it sees an object, it's going to stop, and then it's going to reverse. And let's say it's going to reverse for 5 seconds. We are going to make that just from words and ideas just right into code. So the first bit we need to say is it's going to go forwards. And in this instance, we don't need a pause because we just want it to go forwards for as long as we say. So we want it to always be going forwards unless something happens. In this, or you might say, if we see an object, then stop and reverse. But other than that, keep on going forward. So if we ran this code exactly like it is, we'd know that all it would do is just keep going forward forever. Just like we know that if it was just a smiley face, like we did before, if it was just a smiley face in this forever loop, it would just smile forever. And also we see that there are no pauses. So what we know with just the code we've written is that the code will say on when it turns on, then start showing a smiley face and keep moving forward forever. But the complex bit now that we're going to need some new ideas for is how do we handle if I see an object, stop and reverse. So if is the first thing we don't know about. So we're going to use what's called logic, a specific kind of logic called conditionals. So these, when we call them conditionals because we're defining or we're explaining to the computer the conditions under which we want certain things to happen. In English, the condition would be if there's an object 5 centimeters ahead of me, then I want to stop. And then I want to do this. And then we're going to define what this is, but we're also going to define if there is an object in front of me. This will make more sense as we write it. So we go over to logic, and we're going to click if, then. So what's really good about MakeCode is it is very close to English. So what were we saying that we wanted to do? If there is an object less than 5 centimeters in front of us, then do this. The first bit we're going to do is we're going to do the reverse and the forwards. The stop and reverse. So we don't have to worry about if true yet. We're going to focus on writing the code that we want to run when there is an object in front of us. So the first thing we'll do is we're going to say stop. So if you look anywhere down here, one piece of code seems to make sense to us. So it's this, motor left stop. We can guess that it's the right one because it does say the word stop. The code for the microbits is written in such a way that if you think about it in English, you can probably find the code where you want it. If we didn't know what we were looking for, but we wanted to find the code to make the motor stop, we could literally write stop into this search bar up here, and we might find it. And actually we can see that it is here. It gives us some other ones that we don't need, but if we know that what we want to stop is the motor, then we can immediately be smart enough to know that this is the one we want. So we can drag that out as normal. So remember that what we wanted it to do was stop and reverse. So we could put a pause in because we want it to stop and then wait before we reverse. But because stop is it's the stopping of an action. It doesn't matter how long you stop for, or it just stops straight away. As soon as you call that, all the wheels just cease and stop moving permanently. It's like you've cancelled any kind of movement command that was in any of the wheels, just stops. So we can say motor all stop, and we don't need a pause after this. And then straight away, we know exactly what we need to do on this one, because we've written this before. We want all the wheels to go backwards at the same speed that they came in at to begin with. So what we'll do is we'll say motor all, reverse or backward, and then we'll say speed 150 again. So what this is going to do is say, show an icon, smiley face, to let us know that you're on, move forward as soon as you're turned on, if, and we haven't written the case yet, if something is true, then stop all the motors and move backwards. What we might want to add as well, we don't want it to just move backwards forever. We only want to move backwards for 5 seconds, because we want the thing to be able to then go forward. And say this was like a motion tracking car or a Tesla or something, we can't just stop in the middle of the road. We need to keep moving forward. So we need to stop, go backwards, and after those 5 seconds, we're hoping that the obstacle isn't there anymore, and then we're going to carry on going forwards. So what we'll do is we'll just go backwards for 5 seconds. So now we've come to the more confusing bit that we're going to work out. So we have the words if something, then stop, go backwards for 5 seconds. So now we have to work out, how do we tell the computer, how can the computer work out that there's an object in front of it? So we actually already spoke about this with the ultrasonic sensor. So what we need is to be able to say, if the ultrasonic sensor, or the reading, the number or the value that I get from the ultrasonic sensor is less than 5 centimeters, and it's saying there's something less than 5 centimeters away from me, then I stop, reverse for 5 seconds. So we're going to have to work out how to do that. So we use some things that might be familiar from math lessons. So, you know, less than symbols, greater than symbols. We go into logic and we look for these symbols. So what we're trying to say, remember, is if the number that the ultrasonic sensor gives me, because the ultrasonic sensor is constantly telling the robot how far away it is from anything. So if it was just in space, just on a flat ground, it would just not read any reading. So that would tell it that it was nothing anywhere near. And then if there was something 10 centimeters away, it would say 10. And as that thing got closer, or it moved closer to that object, it would say 10, 9.9, 9.8, 9.7, 9.6, all the way as it gets closer. So, and you can tap into that reading at any time. So we're looking for the less than symbol, which we can see right here. So we're going to take that as a start. And what we're trying to say is, if the number that I'm reading, or the distance that I'm reading from the ultrasonic sensor, is less than, let's say 5 centimeters in front of us, then we stop, we move backwards, and we reverse. So the first bit that we know to do is the 5. So we've added that, but now we need to see how to read the ultrasonic sensor. So let's go through the same thing we've done before. We're going to say ultrasonic, and we see that straight up it comes up with what we want, which is read ultrasonic sensor. So where do we think we should put this? The best place is right in here, and it's starting to look, and we can start to read this and have it make sense to us. So if we try reading through all these points, we can try to work out whether we have written the right stuff now. So we're saying forever. So always, this is the code that's always going to be running on the microbit. Be smiling to let me know that you're on and you're working. Always move forwards. Always be moving forwards. And then if, and only if, the ultrasonic sensor tells me that I'm less than 5 centimeters away from an object. If that's true, then stop, move backwards for 5 seconds. And then once it's done that, it will come out of this loop and then begin running again. And the important thing to remember with ifs is that they only run when this is true. So if it's like a thing that you're checking. So as the robot is always moving forwards, every time it tells itself to move forward, which happens loads of times in a second, if it gets a reading from the ultrasonic sensor and says, oh, the wall is 10 centimeters away, this isn't true. This whole block isn't true, or this case or condition isn't true. And if that condition isn't true, then none of this runs, because it's saying, if this is true, then do this. Otherwise, ignore me. So that's what we're doing. So at this stage, we're at a point where we can run our code and check to see if it's working. But let's have one more read through before we go. So we show the icon, which is the smiley face. We're going to move forward if and only if the ultrasonic sensor tells me I'm less than 5 centimeters away from something, then stop, move backwards and for 5 seconds, and then carry on going, or carry on checking the code. Because think, then the next time this runs, after 5 seconds, we're not going to be 5 centimeters away anymore. And then it's going to keep going forwards, see that this if statement isn't true, skip it, and move forwards again. So I think you got all the understanding now. So you're ready to test out your code and see if it's working. So we'll go through the standard setup. We'll go to the download. Remember to have this off so your microbit doesn't go flying off the table. And also, if you've got your phone handy, this is a really good time to get ready to film it to see if it's working. Maybe even send this to someone who can send it on to me. And let's see what it can do. So I'm unplugging my microbit because the code is already written. So my object today is a skateboard. Here's the microbit. We're going to turn it on. I haven't sellotaped my microbit battery to the back, so there's a chance this might come off. I'm going to turn it on and wait. So R1's going backwards right away for 5 seconds. So clearly our code isn't working for some reason. So we're going to go right back to the drawing board and work out why not. So just coming back now, we saw that the code wasn't working for some reason. So we need to go and have a look at this to work out why it isn't. So if we read through our code, this is what all programmers do when they make mistakes. They have a look at the code and try to work out what is it that's happening that doesn't make sense to us. So the small mistake I'd made, which, can you believe it? The small thing I hadn't done is actually put the ultrasonic sensor on the robot. Maybe you made the same mistake. If your code was already working, congratulations, you outsmarted the teacher. Otherwise, make sure you've got your ultrasonic sensor and you've plugged it in. So this is the one problem with just following other people's code or copying other code from the internet. So we wrote this together, but if you just do what someone else told you to do, you might make a mistake. So making sure that the ultrasonic sensor is now plugged in. If you want to know the complex explanation, what happened is that without the ultrasonic sensor, whenever the robot tried to get a reading, it just went 0, 0, 0, 0. So 0 was always less than 5, and so the robot always went backwards. But now we've plugged it in, so we should be back to normal. So remember to plug in your microbit. You don't actually need to plug in for this time because the code is already on there. So actually, so long as you put the ultrasonic sensor in, now you should be able to run it like normal and the same code will work properly. A bit of tape on the front and back now to keep the batteries in place. We can do our first test. So we flick the power on the back, and what we're expecting it to do is bounce off that skateboard. So we turn it on. We see the smiley face, it says on, and then the smiley, which lets us know it's working. And then we see after 5 seconds it goes forward again. What we do notice though is it is still hitting the object. So it might be that 5 centimeters is just a bit too close because the technology isn't perfect. So we might change our code just a little bit to make it a little bit better. But that seems like a job well done. So just to correct that one strange thing that we saw. So just because the code is right on paper doesn't mean that it will be right when we actually go out there. So this is the difference between things working in theory and working in practice. So it doesn't mean the code is wrong, just that we need to make slight changes and improvements to it. Whenever we're programming, we expect things to not work first time. So we always expect to make mistakes, expect to make errors, and then expect to make them better and fix them and improve them. We always expect that. So actually, and also what that does over time is make us better we make better code, and also we become better coders because we don't make those mistakes again. So what we're going to change this time is we're going to change the reading to 10 centimeters. So if this is right, then what this will do is it will tell us way further ahead that there is an object in front of us. So now we don't expect the robot to even touch the skateboard. We expect it to bounce off straight away. So we'll save the code because it's always important to save the code again because we don't want to lose our project. We'll save it as Collison bot again. We'll plug in our robot. I'll just have to move my tape a little bit. Plug our robot in and download the new code. Remembering that if we can see that yellow light flashing, that the code is going. And when it says download completed, we know we're ready to go. So we will unplug our microbit. Just as a note, the best way to do this, if you click safely remove hardware, it's pretty important that you do this, because 1 in a million times your microbit, because you unplugged it, might just freak out and just stop working. I had this experience with one of the microbits recently, and can confirm this is something that really happens, and it can just happen out of nowhere. Whether it's new or old, this can just randomly happen. But there is a way to save yourself from this happening and losing some equipment. You just always eject, and long term, it'll be a painless life. So I'm going to eject my code, or eject the microbit because I've already written the code. I think the program says it's still in use, so that tells me that I can't actually eject it. So now I will just unplug it and go do another test. Ooh, this is our second test. So we're ready to go this time. We've got the skateboard still set up on the other side of the room, and we're going to go. So we flick it on and see what it does. So perfect. So this time it didn't even make contact with the skateboard, which shows we're in the right place. See? And now it's bouncing back from a distance. So what we can expect the skateboard to do So we switched our microbit on, and now we're testing it another way. We just throw ourselves in front of it. So for some reason, the microbit seems to recognize people better than wood. It might be because of the grip tape on the skateboard. There could be 1,000 reasons. But we've seen the code work sometimes, and we noticed that depending on the object, it works a little bit better. So let's find another object. So for example, a big shoe, big skate shoe. How does it do with that? What it seems to be is that reflective objects, it does less well with, and then objects that aren't very good at reflecting, like us, it does really well at.
So great. Our code is doing exactly what we planned for it to do. Moving forward, detecting an object and then moving back. And we've got a great foundation to start getting really creative and doing really weird things with it. So before we call it though and throw the party, we'll just quickly go through what we've done. So today, what we've been doing is we've just been building our first version of a motion detecting robot, or a collision detecting robot, I should say. What we did is we built code that when it starts up, it tells us that it's coming on and is turning on. Then what we did is we made it show us a smiley face. So it would tell us always that when it's running, and when it's running like normal, then it would just be showing us a smiley face, which lets us know that it's working, it hasn't run out of battery or nothing is broken on it. What our code does then is also it's always moving forward. So our robot will always be moving forward unless there's an object in front of it. When there's an object in front of it, and an object that's less than 10 centimeters in front of us, which is being read by our ultrasonic sensor, if we find out that there's an object in front of us, then instead of just moving forward, we have our code, which is inside this if block, all run instead. So we have the motor stop, we have our robot move backwards, and we wait for 5 seconds before we check that again. Because otherwise, what we would get is when an object was in front of us, our computer would go, back. So we need to wait before we check that again. So if that sounds simple, that's because it is. At the lowest level, if you can explain these things in English, then you really are understanding these things. And often, when we talk about programming, it's much easier and much simpler than we think. So I hope this video has been able to show you that maybe some things that you thought were complex are really achievable, and perhaps you're even better programmers than you realize. So where maybe you can go from here is you could check out maybe editing this code to make it do different things. So maybe instead of stopping and going backwards, we could have it stop and turn left or right. Maybe we could use the buttons, or maybe we could use a remote radio controller in another microbit to have our microbits turn left or right, but us control that. There's all kinds of things that you can use the collision detecting sensor or the ultrasonic sensor for, once you've got this very powerful code right in the middle of it. So have a play around, and if you ever want to include collision detection in your future projects, you can use this video and this code to come back to. And in the process of learning and building this code, there's actually been a load of other things we've learned about. So we've learned a little bit about the search bar feature, which is really powerful and really useful for anything we could want. Even if we don't know exactly what it's called, if we can guess what it might be called, we can probably find it. So for example, looking for sensor, and then we find out where all the sensor codes are, and we know which one we want. Just like that, that's a really useful and powerful feature that will make us better programmers. We learned about that we can change pretty much any function or code block just by clicking on some of its drop-down menus or writing in our own values or using some of the sliders. And we also learned that, most importantly, that we learned about ifs and how do we set conditions for things to happen within our forever loop. So the way we do it is we say, if a certain thing is true, then do this. And the thing that we're doing is always the code that's inside the if block. So this is a really powerful thing. We could do even more conditions if we wanted to, like else or else if, and define more and more conditions for more and more things. For example, if something is 5 centimeters away, we might move back even more quickly, or some other kind of function, or we might turn on the headlights. Another thing that we learned is that there's a way for us to control how long a particular command or a particular order gets followed for, which is a really powerful and useful thing. So for example, if we want to move backwards and we want there to be 5,000 milliseconds or 5 seconds where we're doing this before we do something else, we can put in a pause, which we find in BASIC, which is a simple function or a simple piece of code, but it's very important because otherwise our robots will run 10 commands all in a nanosecond, and it will look like none of them are being followed because too many orders are going in at once. So it's really important that we put breaks in between our commands so that what we call the flow of execution, or the order that things are run, is always respected and runs in a way that makes our robots really useful.
But we can definitely call that now a job well done. So we've got the code to move forward, stop when we want, and then once it's stopped, reverse, get some space, and then go forward again, hoping that the obstacle's moved. So now that you've got to this point, you've got all the basic building blocks that you need to then start making stuff really, really fancy. So if you remember in previous lessons, perhaps on the in-class stuff, what we did is we got the microbit like spinning left, we got it spinning right, we even got it doing reverse turns and like weird reverse backwards turns. All these things are all what is possible. But if you take the code that we've just written now, and then you make small changes, those dancing parts, turning on different lights, all those little steps are just a few lines different. And you can work out all of those lines from what you've heard and what you've seen already. So if you like what you've been doing so far, stay with it, stay creative, get to changing some things, see what is the best thing that you can make it do. And if you've got any cool videos, make sure to send them, because I'd love to see what you can do. So if you understand this, really well done. You've learned a lot in a really short time. Now go and do something that you like even more with it yourself. So show me what you've got. Make sure you send your videos. Well done.